So, to answer this question, we have to first ask ourselves, what is mathematics? What is it? So, mathematics is something that expresses the patterns and the regularities in the universe. It is a language that expresses these patterns and regularities in the universe, right? So, the universe has patterns and regularities, and mathematics is a language that perhaps we have invented to express in the simplest possible form and the most concise possible form these patterns and regularities. So we are discovering these patterns and regularities, but we are expressing them in a language that maybe we have invented, right? So we do discover things in mathematics, and we also invent techniques to discover things in mathematics, right? So if there are intelligent aliens out there, maybe they use different notation for doing their mathematics. So maybe it's a language, it's a different language that they've invented, and it's a different language that we have invented, right? But these languages, whatever they do express the same things about the universe, the same patterns and regularities. So mathematics is invented, it is also discovered, because we are discovering facts about the universe. For example, mathematicians are always several steps ahead of physicists. They talk about infinite dimensional spaces, they talk about various things that physicists have no use for, and then 100 years down the line, we suddenly find a use for one of these things that mathematicians have been doing, supposedly random abstract things that mathematicians have been playing with, For example, you have group theory, Galois theory, which was discovered in the 19th century, or discovered, invented, whatever you call it, by a French teenager, right? And for 100 years, it had no application of any kind. It was something abstruse and abstract. And suddenly today, in the 20th century, it found a great use in particle physics, in symmetry, in the symmetry groups in particle physics. So that's an example of how ahead of the times mathematicians are. So they discover things about the universe, regularities and symmetries of the universe, and they express them in the language of mathematics. And like I said, they also invent tools and techniques to solve problems which enable them to make discoveries about the universe. For example, you have various differential equations and tools and techniques of solving differential equations and matrices and numerical analysis and whatnot. So these are tools that are invented to make discoveries. So I would say that mathematics is both invented and discovered. It does tell us something very profound about the universe. It does help us understand the universe better. There's only one mathematics. There are no parallel branches of mathematics that differ from each other. 2 plus 2 is always 4. And the area of the circle is always pi r squared, right? So unless you're on a curved surface, in which case it's something else. So in curved geometry, the area of a circle is different, etc., or a triangle, etc. So that's how it is. So for example, Pythagoras theorem, we know what it is on a flat surface. It's different on a curved surface, but that holds true for the entire observable universe as far as we know. So to make it short, I think mathematics is something that is invented as well as discovered. Tools and techniques of mathematics are invented, but the deep underlying patterns and regularities of the universe that mathematics expresses are actually discovered. So that's what mathematics is. It is the most logical language that we have, and it's the language of physics. So there's no physics without mathematics.